Section 4.4 is titled Determinants and Cramer's Rule. In this section, we're going to go over another operation with matrices called determinants. I'm going to show you how to do it for 2x2 and 3x3 matrices. And then we're going to use determinants in a variety of ways. We're going to use it to solve systems of equations, and also I'm going to show you a formula with determinants to find areas of triangles. Now, a determinant is a real number a real number that every square matrix has. Has to be a square matrix, okay? Square meaning 1 by 1, 2 by 2, 3 by 3, 4 by 4, etc. Notations for determinant, there's a couple that we see. You can see written like this. And the capital A can be any matrix name, but just DET matrix. Okay, that tells you determinant. You also see that the brackets get replaced with what looks like absolute value bars. They're not absolute value bars. I don't mean absolute value, but just the two parallel lines will surround or encompass the matrix instead of these square brackets. And when you see that, it means determinant as well. For a 2 by 2 square matrix, the determinant can be found this way. You take the product of A and D minus the product of B and C. That's it. Okay, seemingly kind of funny random computation, but that's how we compute the determinant. So down here I would take 5 times 3 minus 4 times negative 2. That's 15 becomes plus 8. So the determinant is 23. Okay, again, notice that the determinant is not a matrix. The determinant is just a number. Okay, that's important to understand. When you do this, you're just getting a number, is all. The determinant for a 3 by 3 is slightly more involved than that for a 2 by 2, but it's in concept kind of the same. The way I do it is this. I take the first 2 columns and I rewrite them behind the matrix. So I'm going to put A, D, G, B, E, and H. I'm going to put them behind the matrix like that. And then I'm going to take the same diagonal that I did in the 2 by 2 and start with the top left corner, work my way down, except I'm going to have to do that 3 times. Okay, so I find all of these products. I multiply A, E, I together, plus B, F, G together, plus C, D, H together. Minus, so just like in the 2 by 2, minus here, and now I take the diagonal that comes from the bottom left hand corner up to the top right. But I had to take all 3 of these diagonals. And they're all products along the lines. So GEC plus HFA plus IDB. It's confusing with all the letters, and don't memorize the letters because that's not going to be helpful. Just memorize kind of how you do it. It's the 3 diagonals coming down minus the sum of the 3 diagonals going up. Okay, you'll see in an example it's really not that bad. Alright, 3 by 3 determinant. First thing I do is I copy the first 2 columns behind the matrix. Like that. And now I'm ready to do all my diagonal products. So the first diagonal, second, and third. So the diagonal is coming down. So that's going to be 3 times 4 times 6, which is 72, plus 2 times 1 times 4 is 8, plus 5 times negative 2 times negative 3 is 30 minus. Now I want the diagonals coming up. So 4 times 4 times 5, 80 plus negative 3 times 1 times 3, that's negative 9 plus 6 times negative 2 times 2, that's negative 24. So let's see, adding up here I get 110 minus, and if I add up here, let's see, this is 33, take away from that, so that would be 47. 110 minus 47 would be 63. If my math is correct, hopefully it's correct. Now let me show you that you can do these determinants on a calculator. And I want to show you how to do it on the calculator, because if you encounter something larger than a 3 by 3, I want you to just use the calculator to do it. So if you had a 4 by 4, you'd want to do what I'm going to show you next. Okay, I begin by going into my matrix menu. I'm going to go over to Edit. I'm just going to pick the first one because I don't need what's there anymore. I'm going to make this 3 by 3. I'm going to type in the 3 by 3 matrix that we're looking at on this slide. So 3, 2, 5 is the top row. Negative 2, 4, 1 is the middle row. And 4, negative 3, 6 is the bottom row. I'm going to quit to get out of this screen. So I'm back on the home screen. I'm going to go back into Matrix, go across to Math, middle tab. First one there says DET. Go back to Matrix. Where I typed it in was matrix A, so I pulled that out, so now it's going to do determinant of matrix A. And the answer is 63. Next I want to go into an application of determinants. It's called Cramer's rule. Cramer's rule gives us a way to solve systems of equations. I'm going to begin with the 2 by 2 system of equations. What we're going to do is set up a ratio of determinants to solve for x. I'm going to set up a ratio of determinants to solve for y. Since this is a 2 by 2 system, we're going to use 2 by 2 determinants. Okay, here's how we put the numbers in. The determinant in the denominator is just simply the coefficient matrix. If you see this side of the equation as a matrix, dropping the variables, that's the denominator. So 2, 3, 3, 2. Okay, there's the setup for the denominator. Now the setup for the numerator is slightly different. If you notice that in this system of equations, the first column contains x's, second column contains y's. Well, if you are going to solve for the x's, what you do is you take the x numbers out, and in their place you put what the system equals. So I'm going to put negative 1, 16 where the x numbers should be. I'm just going to fill in what the y numbers are. Okay. If I'm solving for y, I do the same thing, but I replace the y numbers with the negative 1, 16, and I keep the x numbers as they are. Okay. So there's my setup. It looks complicated, but once you do it a few times, it's really not that bad. Now we're ready to do the determinant computations. So it's this diagonal minus this diagonal, which is negative 50. Down here it's this diagonal minus this one. Since I'm dividing negative 50 divided by 5, negative 5, x equals 10. Over here I do the same thing. This diagonal minus this diagonal. That's 35. This one is the same thing as it was over here. I divide these. So y equals -7, and I have my solution, 10 comma -7. So what we have with this Cramer's rule gives us is another way to solve these systems of equations. I didn't do substitution, I didn't do elimination, I didn't graph the lines. Okay, it's a completely different way to solve the system. I have one more here of a 2x2 system. Again, you can try this one on your own if you want, and then push play when you are ready to resume and check your work. I'm going to go ahead and begin, so if you want to try on your own, just hit pause. Okay, the denominator 2x2 matrix is 8, -3, 3, -2. Notice the minus in the equations interprets as negative numbers down here. Okay, the numerator, when solving for x, I replace the x column with what the equations equal, which are 20 and 11. I keep the y numbers. Over here on the y, I replace the y numbers with 20 and 11, and I keep the x numbers. Okay, there's our setup. Now we are ready to solve this. So let's see, the numerator here, I have -40 minus -33, which is -7. And here we have -16 minus -9, which is -7. Divide those, x equals 1. On this one, I've got 8 times 11, which is 88, minus 3 times 20 is 60. So that is 28. Down here, it is still -7. Divide those, I get y of -4. So our solution is 1, comma, -4.